are looking at the last section of the Unit 6 that talks about chain rule and validity of implications. By the end of this section, you should be able to construct chain rule of implication and determine the validity or otherwise of implication or conclusions. So, if this statement P is less than 3 and Q S is less than 5 and R S is less than 8, then P implies Q. If S is less than 3, then S is also less than 5, and R is going to give us if S is less than 5, then S is less than 8. Yeah, so when you look at it, our universal will be integers. A number is less than 3, B number is less than 5, C number is less than 8. So A is a subset of B, B is a subset of C. Then we form the chain rule by saying A is a subset of B and B is a subset of C. The conclusion will be that A is a subset of C. And this is the Venn diagram that is showing it. So the resulting chain rule is P implies Q and Q implies R, implies that P implies R. Hence P implies Q, P implies so this is what our chain rule can be written. And let's take another question. If students study mathematics, then he or she is in the mathematics club. If a student is in the mathematics club, then he or she does not play tennis. Then there's a second one. So let's look at the first one. So we can form a simple statement. P. A student study mathematics. Q. A student is in the mathematics club. R. A student does not play tennis. So we can conclude by saying that the chain rule will look like this. P implies Q, this implies that, and the conclusion is that P implies Q. That is, if a student studied mathematics, then he does not play tennis. So the next question, S is an odd number, S square is odd, S plus 1 is even. So the implication in this statement are that we therefore form the chain rule, and the conclusion will be that if P implies Q, if S is an odd number, then S plus 1 is an even number. Any odd number plus 1 becomes an even number. Validity of implications. In proving a theorem in mathematics, we make a sequence of statements, usually starting from some chosen statement and ending with a final statement called conclusion. In real life, we often argue cases out by making a series of related statements and establish a conclusion at the end. Often, a premise is chosen, and the argument is based on the given premises. So consider the following statement. Disobedient children find themselves in jail. So if Alec is disobedient, he will be jailed. All brilliant students study hard. So if you study hard, then you are brilliant. If Ali study hard, then Ali is a brilliant student. So let's look at them. This compound statement Q is made up of two simple statements. Aleph is disobedient. Aleph will be jailed. The statement Aleph is disobedient is a specific case, and Aleph will be jailed is a form of conclusion based on the given premises and the specific case. However, we have to determine whether the conclusion drawn is valid or not. So our set is children, the universal children, the set is disobedient. J will represent those who are jailed. So whereas that those who are jailed is the bigger circle. D is all disobedient children. Ali is a disobedient child, so Ali is here, and Ali is automatically in the jailed days. So therefore, that statement is a valid statement. So we need to explain to the student that from the second advice, we obtain the following statement. All brilliant students study hard. That's the premise. And if you study hard, you will be brilliant. So let's look at the statement. 1. You study hard. That's a specific case. Then 2. You will be brilliant. That's the conclusion. So let's look at the conclusion there. From the diagram, you have that B is a subset of H, but there are two possible positions for particular students. Why? If you are a particular student who study hard, you can be outside the set B, but in H, you study hard. You study hard, but you are not brilliant. It's possible. So any statement that gives a different possibility is not a valid statement. That gives several possibilities. Any statement that gives several possibilities. So the set of students who study hard, H is a set of students who study hard. A particular student Y can be in the set of students who study hard. A particular student Y can also be in the brilliant set. For all brilliant students, they study hard. So if you are within the brilliant student, then that statement becomes a valid statement. But if you are outside the brilliant student, then though you are a hard student, but you are not brilliant, so that statement becomes an invalid statement or not valid statement. So the conclusion does not hold always followed from the premise. If in a sequence of statements, each statement follows logically from the previous ones, we say the argument or conclusion is valid. An argument refers to the sequence of statements. That's another question here. Form a valid conclusion from the following statement. The statement is: people from this village are Christians. Kojo is not a Christian. So the next one is state whether. So the next one is state whether a statement S is valid conclusion from the statement P and Q. Thus, P is all girls like studying English. Q, those who study English speak it frequently or fluently. S, Hawa speak English fluently since she is a girl. So when you look at this one, the universal is people. That's people from this village. C, Christians. So you realize that Kojo is not a Christian and Kojo is not from this village. The diagram shows, therefore, the conclusion that Kojo is not from this village. Therefore, the conclusion is that Kojo is not from this village, and this is a valid statement. Alright, so this is our solution for the second question. Universal as people, we have set of girls. Then we have English, those who speak English. Then we have those who speak English fluently. Those who speak English, some may not be fluent. So we have those who speak English fluently. Then we said Hawa speak English fluently and Hawa is a girl. So since Hawa is a girl, she's here, and she's within those who speak English fluently. So from the diagram, we have that Jane, the girls, is a subset of those who speak English, and those who speak English is a subset of those who speak English fluently, and Hawa belongs to Jane. Therefore, our statement S is a valid conclusion from P and Q. This is the end of this session, which teaches us the chain rule of implication and determine the validity or otherwise of implications or conclusion. So that's what we learned for today or for this session.